Okay, welcome back. We're going to be looking at the endocrine system and some of the major organs and glands of it. We're going to start with the hypothalamus. Here's the hypothalamus. Here's the pituitary gland that sits in the hypophyseal fossa of the sella turcica, part of the sphenoid bone. Here's the infundibulum. That's your optic chiasm. If there's a pituitary tumor and that becomes enlarged and it pushes up against the optic chiasm or the optic nerves, it will create some visual disturbances. Make sure you know the anterior and posterior pituitary, the adeno and neurohypophysis. The neurohypophysis has axons that connect from the hypothalamus to the posterior pituitary. It's only involved with two hormones, oxytocin and ADH, while the anterior pituitary is involved with 7 hormones. You should know what they are and their functions. Let's move to the torso, and we'll start with the thyroid, which means shield, and it does look like a shield. It has 2 lobes and an isthmus that connects the two. And behind the thyroid are parathyroid glands. There's a parathyroid posteriorly. We can't quite see it too well here, but on the posterior side, there is a parathyroid gland superiorly and inferiorly on the left and right side. The thyroid gland is responsible for producing T4, which is thyroxine, and T3, triiodothyronine, as well as calcitonin. The thyroxine, the T4 hormone, is responsible for your metabolism. Calcitonin is responsible for calcium levels in your blood. If the serum calcium levels are too high in your blood, calcitonin is the hormone released by the thyroid to help put it into the bone. Okay, to increase osteoblast activity. Whereas the parathyroid gland works antagonistically to that. Both involved with calcium sensing in the serum. If the calcium levels are too low, parathyroid levels, the parathyroid kicks in producing PTH, parathyroid hormone, which stimulates osteoclast activity to break down the bone. Okay, let's go down to the lungs. The lungs make ACE, or angiotensin converting enzyme. An angiotensin converting enzyme is responsible for converting angiotensin 1 into angiotensin 2, which raises your blood pressure. Let's remove the lungs. And we can see the liver. The liver is responsible for producing insulin-like growth factor, as well as angiotensinogen, which is the inactive form of that hormone. Now we can see, here's the esophagus, which brings food into the stomach. The stomach helps release pepsin. The cells of the stomach produce this hormone or this enzyme to break down proteins, and that's very important. After the stomach, we have the beginning of the small intestine, called the duodenum or duodenum. And if there are fats that are in the stomach that move into the duodenum, the fats will stimulate the duodenum to release cholecystokinin. And cholecystokinin will then go to the gallbladder and make the gallbladder contract to release bile, which is responsible for emulsifying the fats. The bile is made, however, in the liver. The liver makes the bile, but the gallbladder, behind it, you can see here, stores the bile, and it's the cholecystokinin released by the duodenum that's responsible for its release. Now we have the pancreas, and the pancreas releases insulin. It's the beta cells of the pancreas that releases insulin that's responsible for lowering blood sugar. And if the blood sugar gets too low, the alpha cells can release glucagon to increase blood sugar. Okay, then we've got the kidney. Here's the kidney, and the kidney makes renin, and it makes erythropoietin. Renin is involved with trying to increase your blood pressure, and erythropoietin is responsible for increasing red blood cell production. That erythropoietin goes to the red bone marrow and stimulates erythropoiesis or red blood cell production. The kidney is also involved in making another hormone called vitamin D. Above the kidney is referred to as renal, so above it is the adrenal gland or adrenal gland. And the adrenal gland has an outer portion called the cortex that makes your glucocorticoids, cortisol, cortisone, and corticosteroid. And it makes a mineral corticoid called aldosterone. And it has a medulla, or an inner portion, that makes catecholamines, and that's your adrenaline and noradrenaline, referred to as epinephrine or norepinephrine. That's involved in your sympathetic neural system fight or flight response. Okay, let's look at the heart. The heart has the atrium, and the atrium of the heart has these receptors that senses what your blood pressure is, and it releases a hormone called ANP, atrionatriuretic polypeptide. And atrionatriuretic polypeptide works antagonistically to ADH, which is anti-diuretic hormone. If your blood pressure is too low, your body will want to conserve water, so the pituitary, the posterior pituitary, releases anti-diuretic hormone. And that anti-diuretic hormone will allow your body to retain water, which will increase the blood pressure. However, if your blood pressure is too high, the atrium releases atrionatriuretic polypeptide. Natrium, if we take the first two letters, Na, is sodium. So if the blood pressure is too high, that hormone is released, which allows your body to get rid of sodium. And if you're getting rid of sodium, you're losing water with that. So it has the opposite effect. And when you lose sodium and you lose water, your blood pressure drops. So we hope that gives you some good insight into the endocrine organs and the production of their hormones. We hope you study well. See you soon.